What if I told you that you could take an ordinary amateur telescope, a telescope that you could buy from a department store or any telescope store, and image redshifted galaxies over 3 billion light years away? Would you believe me if I told you that not only have I done just that, but I have also imaged quasars almost halfway across the visible cosmos? And recently, I've captured images of a number of quasars that are in the vicinity of 20 billion light years away. Because I have, and you're looking at one of them right here. And I'm pretty sure you can do this too. First of all, I'll show you where in the sky I captured these images, and then we'll take a look at how I know that I captured these images. This is Messier 82, also known as the Cigar Galaxy. It is a starburst galaxy where very rapid star formation is going on, and it is visually striking due to the large amount of ionized matter that is being ejected from both poles of the galaxy. It's actually much larger than it appears too, on either side of the narrow side of the disk. It has galactic arms that extend out several times the disk's length. However, due to obstructions such as dust, they can only be perceived by infrared cameras. Messier 82 is 5 times brighter than the entire Milky Way galaxy, and its central region is 100 times brighter. The term starburst means that the galaxy has very active star formation going on, and in the center of Messier 82, stars are being formed 10 times faster than they are being formed throughout our entire galaxy. At right about 12.5 million light years away, or megalight years, Messier 82 is the closest known starburst galaxy to Earth and gives us something of an inside view of the mechanics of a starburst galaxy. Yet as visually striking as this galaxy is, it is not the most amazing thing in this photo. To me at least, not by far. Because if you look carefully at the space all around Messier 82, down here there is a reddish cluster of objects, and we have another such cluster up here. These are redshifted galaxies, and not just their apparent small size, but the intensity of their redshifting indicates they are indeed very far away. And there are numerous small, or rather distant galaxies scattered all throughout the photo. Let's take a quick look at some of them. There's an incredibly powerful tool that can be used to analyze everything that's in this image. It's created by a fellow named Frank, and the tool is called the SETI Astro Suite. I'll put it up on the screen now. The SETI Astro Suite has been made available for free by its creator, and it's always in development, always getting better, and sometimes amazingly fast. It offers tools for color correction, continuum subtraction, sharpening and denoising, and many other powerful options. But of all the tools the SETI Astro Suite offers, by far my favorite is the tab What's in My Image. When on this tab, the SETI Astro Suite will plate solve an image, and then the user can direct it to analyze and annotate the image, revealing potentially hundreds of different kinds of objects within an image. So I've already directed the SETI Astro Suite to plate solve the image. Let's use it to reveal the distant galaxies hidden away within this image. After running the plate solve in the search tool, several dozen remote and distant galaxies are revealed in the search. I'll zoom in a bit so that we can get a closer look at them. Now there's a small search box on the lower left, and you can see green lines running through the top and bottom of it. That will reveal the search area. I'll zoom in to narrow down the search area. Now, I'll drag the search area over a region of interest, a region where some of the red circles appeared. In particular, I want to check out the region on the lower left where I saw the cluster of redshifted objects. Notice the red circles within the search box and on the primary image center right. Each one of those is set over one of the galaxies that has been found in the plate solve. Now I'll circle that readout again. You'll notice data on there laid out like a spreadsheet, and it contains vital information on the galaxies portrayed. And if I click on any one of the galaxies on the screen, that information will be highlighted in the readout. Let's start with one of the larger, brighter galaxies within the cluster. Its designation is SDSS J095335. We can see on the readout that it is significantly redshifted by 0.28109. indicating that it is very far and moving away from us very fast. And by going just to the right and looking at the co-moving radial distance, we can see that it is some 3.7 gigalight years away, or 3.7 billion light years away, which makes SDSS J095335 the furthest galaxy that I can confirm that I have ever imaged. Though there are many other galaxies in this image of an amazing distance. Let's take a quick look. This target shows up at 2.8 billion light years away, but I'm going to rule it out from consideration since right now it's invisible. It may show up with more integration time, and I do plan to put at least 20 more hours of integration into this image, but I'm only going to consider visible targets, which is to say targets I've actually been able to capture with my telescope. And right beside it is a target that does show up in the image. However, it has not been measured yet, so there is no data on its redshift nor its distance. The larger galactic structure right beside it is easily visible and so qualifies for our consideration, and it has been measured. It is redshifted at 0.21428 and is 2.867 or 2,867,000,000 light years away. Now, I don't know about you, but I think that's pretty good for a 203mm or 8-inch reflector telescope. And if you're curious, the telescope that I'm using is your basic Celestron C8, not the Edge model. Up here is another visible and thus valid target for our consideration. It is SDSS J095340. It is redshifted at 0.24243, indicating it is very distant and moving away from us fast. And it is 3.221 gigalight years away, or 3,221,000,000 light years. I could go on and on like this. After all, there are dozens of tiny galaxies hidden off in the distance within this image. But they really aren't the most impressive thing. Let's take a look at the quasars. Yes, I have captured quasars in this image, and they are of a distance that is truly staggering. I'll clear the last search and direct the SETI Astro suite to search for quasars here. And the search reveals, amazingly, about a dozen quasars scattered throughout this image. Down on the lower left, where there was the cluster of redshifted galaxies, there are also several quasars. And there is another group up here, just to the upper right of Messier 82. Let's take a look first at the quasars that appear among the group of galaxies on the lower left. By the way, I don't know that any of these things are actually a gravitationally bound group. I'm just referring to them as a group because, at least on the image, they appear relatively close to one another. But in terms of depth, they could be billions of light years apart. One of those quasars, designated DWH M82-4, is redshifted at 0.221 and 2.952 gigalight years, or 2,952,000,000 light years away, putting it in the vicinity of the rest of that galactic group. I don't know if it is technically part of that group, but it is certainly in the vicinity. And there's another quasar in this part of the image. Let's take a quick look at it. It's just right up here. It is DWH M82-3, light shifted at 0.19 and measured at 2.557 gigalight years away. So this quasar, while it's close, at least in the two-dimensional proximity of this image, in terms of three-dimensional space, it's quite distant from the rest of those galaxies. In fact, about a 500 million light years distant. And as noted at the beginning of the video, these are co-moving radial distances. It is in fact hundreds of millions of light years away from those other galaxies. For contrast, here's Messier 82, only 12.5 million light years from us. Let's take a closer look at the former quasar. We can double-click its information in the readout or the designation circle, and that'll take us to an image gathered by professional observatories. The little white dot, dead center, just between the more distant galaxies to the left and right, is our quasar. This is information that was gathered with professional, multi-million-dollar telescopes of objects some 2.5 to 3.5 billion light years away. A distance that we can put a number to, but our minds just cannot truly wrap themselves around it. But amazingly, here are the same objects that I shot with my ordinary Celestron 203mm or 8-inch Schmidt-Cassegrain telescope. With an ordinary telescope valued at less than $2,000 Canadian, it is possible to image targets deep, deep into the depths of the cosmos. But if you think that's impressive, as they say, you ain't seen nothing yet. Let's take a look at the upper right side of the Cigar Galaxy. There were a couple of quasars up that way. Now, watch this. I've just clicked on the quasar designated QSO B0953 plus 698b. A lengthy designation, but there are a lot of objects in space. That quasar is redshifted at 2.04. It is extremely distant and rocketing away from us due to the tremendous speed of the expansion of space at that distance. And it is 17.392 gigalight years away. And once again, that means 17,392,000,000 light years distant. And it qualifies as an image for our consideration because even though it just looks like a point of light, a star in this image, it is visible. And we can double click on the readouts and take a closer look at it as shot through professional telescopes. It may look like just a star here, but this is a quasar, one of the most energetic and active objects in the known universe. Almost 17.5 billion light years away. That's almost halfway across the known universe. And if I turn off the green circle that designates it in the SETI Astro Suite, we can see it right here. But we can yet look much deeper into the cosmos. This is VV96J09573. This quasar is redshifted an entire 2.24 and is 18,301,000,000 light years away. To my knowledge, this is the furthest confirmed quasar that I have shot. Let's take a quick look at it and then see if we can see even deeper into the cosmos. This is that quasar imaged and cataloged through professional telescopes. And if we zoom out a little bit, we can see a tiny galaxy just to the lower left, which I've already plate solved and found to be about 500 million light years away. Let's go back to my image and take a look at both the quasar and the galaxy. There's the galaxy here, just up and to the right. When you think of what can be accomplished with an ordinary amateur telescope these days, it's pretty amazing, isn't it? But there's more. I've zoomed back out on Messier 82, and we're going to take a look at a single, very faint point just above and to the right. This is 2XMM J095752, a possible quasar located in the region. And this quasar is the most distant thing that I know that I have imaged to this date. It is 21.52 gigalight years, or 21,520,000,000 light years across the cosmos. That is nearly halfway to the edge of the visible limits of the cosmos. Let's take a little closer look at it. I'll just remove the designation circle. There it is, a few red pixels in a vast deep sky. But nonetheless, there it is. It is deeply red colored because it is deeply redshifted at 3.12, moving away from our Earth and our galaxy at unfathomable speeds. A distant, almost unnoticeable point of light racing off into the deep dark of the cosmos. Let's take a look at what was revealed of this quasar through the professional telescopes cataloging it. There it is, a small dot dead center. And here it is again from my telescope, a small 203mm aperture Schmidt-Cassegrain operating from the backwoods out of a tiny homemade observatory. Huh, what an age we live in, isn't it? An era where any one of us can make a small investment sufficient to open our eyes to the wonders of the cosmos. At least to about the visible edge of it, currently estimated to be some 46.5 billion light years away. It's really humbling, isn't it? Whole galaxies, mere pinpricks of light on a sensor. And mighty quasars receding into the vast depths of space-time, leaving us only echoes, the faintest traces to remind us they ever existed at all. And here we are, small beings on a small blue world, looking up with awe and wonder at a cosmic ocean we barely understand. Welcome to the cosmos and the story of the sky. It is humbling and awe-inspiring and hope-endowing all at once. Thank you for watching. If you have any thoughts, observations, or questions, please leave them in the comment section below, and as always, I'll get back to you as fast as possible. And if you've been wondering if it's worth it to you to invest in a camera, a telescope, and a mount, I certainly hope this video has inspired you to do so. Now, get out there and shoot the sky. And if you don't have a camera and a telescope, all you have to do is go out by night beneath dark skies and look up to find yourself also sharing in the awe and wonder of a vast cosmic ocean.